Hello, you guys. Let's talk about 7.3, products, quotients, and roots of monomials. Well, that word monomial should be new to you, okay? It means only one term. Like the prefix mono, or the monorail at Disneyland is only one track. This means only one term. So 3x to the second power is an example of a monomial. Just plain old y is an example of a monomial. 2ab is an example of a monomial. But take a look at this one. X plus 2 is not a monomial. This has two terms, so this would be a binomial. Okay, so take a look at example 1. If we were just multiplying, let's say I had negative 4x times 3x to the fifth power. Well, their first direction is really important. Expand the expression. So that means separate everything with multiplication symbols. So you'd have negative 4 times x times 3 times x to the fifth power. And then regroup the factors. So I put all the numbers in front. So negative 4 times 3 in front. And then I put x times x to the fifth power at the end. And then you could just multiply. You know, negative 3 times 4 is negative 12. Times x to the first power, use your red and put that 1 in there, times x to the fifth power. And now we use what we learned last time, that when the bases match, I copied the x, the base, and then I added the exponent. So 1 plus 5 would give me 6. So my final answer is negative 12x to the sixth power. Okay, take a look at b. Let's say I had in parentheses 6ab to the fourth power, all raised to the second power. Well, remember, this is the one where we want to draw the rainbows. So I'm going to draw a rainbow from the 2 to the 6, from the 2 to the a, and from the 2 to the b to the fourth. So I write 6 to the second power times a to the second power times, and notice how I leave b to the fourth in parentheses, all raised to the second power. And now I just simplify. 6 to the second power is 36. A to the second power I just bring down. Now b to the fourth power raised to the second power, well, that's when I use my red and I circle the 4 times the 2. So that gives me b to the eighth power. So I have 36, a to the second power, b to the eighth power. All right, take a look at example 2, letter A. I have 10 a to the fifth power, b to the second power, over 2 a to the third power, b to the fourth power. Well, they're telling you to expand, and what I say is kind of match things up. So notice how they matched up the numbers. They put 10 over 2, and they put times, and then they matched up the a's, a to the fifth power over a to the third power, and then put times, and then they matched up the b's, b to the second power over b to the fourth power. So now we just simplify. 10 divided by 2 just gives us 5. Now, and then they copied the A's and the B's, okay? So now I'm going to bring down the 5. Now, let's use what we know. When it's a to the fifth power over a to the third power, the bases match, so I copy the a, and then subtract the powers from top minus the bottom. So 5 minus 3 gave us 2. And then, same thing with the b's. When the bases match, I copy the b, and then subtract the powers in order. 2 minus 4 gives us negative 2. Okay, now remember, this baby is not happy. So this parent and this baby, they're going to climb into the pool. So everything else stays on top. So it's 5a to the second on top, and then b to the second down in the denominator. Okay. Hi, Kitty. Do you want to say hi to everybody? All right, take a look at b. So now I have p to the fourth power over q, all raised to the third power. So use your rainbows. So give the 3 to the p to the fourth power, and give the 3 to the bottom, to the q. So notice how I wrote p to the fourth power in parentheses, all raised to the third power, over q to the third power. And now I wrote the p and circle the 4 times 3. So that's p to the 12th power over q to the third power. All right, you guys, let's try the guided practice. Sorry, Kitty really wants to help me today. She must love algebra. Okay, take a look at number 1. I have 5n to the third power times negative 4n to the second power. So remember, first thing we do is we write it out. So it's 5 times n to the third times negative 4 times n to the second power. And then regroup it. So put the numbers together first. So 5 times negative 4 times n to the third power times n to the second power. And then we want to multiply. 5 times negative 4 gives us negative 20. And then notice how the ends match, the bases match. So I put the n there, and then we just add the powers. 3 plus 2 gives us 5. So it's negative 20 n to the 5th power. Okay, take a look at number 2. We have 3 times ab to the 4th power, and that's being multiplied by 9a to the 2nd power, b to the 5th power. So the first thing we do is write it out, and so now I'm just going to organize it in one step. So it's 3 times 9, and then I put the a's together, times a to the 2nd, and then I put the b's together, times b to the 4th, times b to the 5th. And now I just multiply. 3 times 9 is 27. When the a's match, I copy the a, and I add the powers. 1 plus 2 gave me 3. And the b's match, so I copy the b, and I add the powers. 4 plus 5 gave me 9. Okay, take a look at number 3. Now, in parentheses, we have 4x squared y, all raised to the 3rd power. So draw the rainbows. So the power of 3 is going to go, sorry, that was a cat. Okay, the power of 3 is going to go to the 4. It's going to go to the x squared, and it's going to go to the y. So I wrote 4 to the 3rd power, and then in parentheses I put x to the 2nd power raised to the 3rd power, and then times y to the 3rd power. So 4 to the 3rd power is 64, and then I copied the x, and I circled the 2 times 3, so it's x to the 6th power, and then I just brought down y to the 3rd power. Okay, take a look at number 4. 2x to the 10th power over 6x to the 3rd power. So match things up. I put the 2 over 6 times, and then I put the x's over each other. Well, 2 over 6, I could divide both by 2 to get 1 over 3. And then with the x's, the bases match, so I copy the x, and then I subtract the powers in order, top minus bottom. So 10 minus 3 gave me 7. So this is just x to the 7th power over 3. Take a look at number 5. I have 9y to the 4th power z over 9y z to the 2nd power. So just match things up. Match the numbers, 9 over 9 times, and then match the y's, y to the 4th over y to the 1st power, and then match the z's, z to the 1st power over z to the 2nd power. And now do it one at a time. 9 divided by 9 just gives us a giant 1. The y's match, so I copy the y, and then subtract the 4 minus 1, so it's y to the 3rd power. And then the z's match, so I copy the z, and then I do 1 minus 2, which gave me negative 1. So remember, z to the negative 1, that baby's not happy, so it's going to go into the pool. So that gives me y to the 3rd power on top over z to the 1st power on the bottom. Okay, take a look at number 6. So I have in parentheses 5d to the 4th power, all raised to the 3rd power, over f to the 3rd power. Well, first thing I have to draw rainbows. The power of 3 goes to the 5, and it's going to go to the d to the 4th. So I have 5 to the 3rd power, and then in parentheses, d to the 4th power raised to the 3rd power, over f to the 3rd power. Well, 5 to the 3rd power means 5 times 5 times 5, which is 125. And then I circled the 4 times the 3, so it's d to the 12th power over f to the 3rd power, and I'm done. Okay, this is really cool. Square roots of squared expressions. If a is a non-negative number or expression, then the square root of a squared is just a. And so in algebra, if I'm taking the square root of a to the 2nd power, I just get a. Or in numbers, if I'm taking the square root of 4 to the 2nd power, I just get 4. Now, something that was really cool that one of my 7th graders shared a few years ago, they saw it like this. If I was going to do the square root of 7 to the 2nd power, I told them that anytime a square root touches a power of 2, they destroy each other. So they took their red and they crossed out the square root and the power of 2 until they just saw the 7. And so that's how they remembered that the square root of 7 squared is just 7. So the other thing I want you to know is that the square root chops the exponent in half. So see how it was a 2 here, it cut it in half, and it became that invisible 1. Okay, so take a look at example A, the square root of 36z to the 2nd power. Well, the first thing I want you to do is write 36 as a square, which is just 6 to the 2nd power times z to the 2nd power. And then the square root morphs around each one. So rewrite it as the square root of 6 to the second power times the square root of z to the second power. And then remember, the square root chops the power in half. So that becomes 6 to the first power times z to the first power. And, the power of 1 is invisible, so it's just 6z. Take a look at c. If I have the square root of a to the fourth power times b to the eighth power, well, the first thing you want to do is separate it. So it's the square root of a to the fourth power times the square root of b to the eighth power. And then remember that the square root chops a power in half. So this 4 gets cut in half to become a 2, and this 8 becomes cut in half to be a power 4. So it's just a to the second power times b to the fourth power. Okay, so take a look at number 7. If I have the square root of 25x to the second power, rewrite it as the square root of 5 to the second power times x to the second power. So the square root of 5 to the second power, remember, it chops that power in half, so that becomes 5 to the first power. And then the square root of x to the second power chops that one in half to be x to the first power. Well, 5 times x is just 5x. Take a look at number 9. The square root of c to the sixth power, d to the second power. Well, first, separate them. The square root of c to the sixth power times the square root of d to the second power. And then let the square root chop the power in half. So the 6 chops in half to a 3, the 2 chops in half to a 1. So c to the third power times d to the first power is just c to the third power times d.